In the previous unit, we finished creating basin model for Cedar Creek. So the loss methods have all the parameters assigned as you see here on the left. Similarly, the transform method has all the parameters assigned. And then if we click on reach, we have the Muskingum parameter assigned. So the next step now is to input rainfall information to drive this hydrologic model for Cedar Creek. So the rainfall information will come from the Excel file that is provided to you. So there is an Excel file in your data set called cedar underscore observed. And if you open that file, you will see three columns. So the first column has date, which is in the form of year, month, day, hour, minutes, seconds. And then you have rainfall in millimeter per hour. And then you have the discharge in meter cube per second. So let's create a rainfall gauge so we can input rainfall information. So before we do that, we want to make sure that we get the time and date right. So the rainfall event that is given to us occurred on 21st of February 2005, and it started at 1 a.m. and it finished at 14 hour or 2 p.m. on the same day. Let's go ahead and create a gauge that will have this rainfall information in millimeters, and it has the same time window that is given to us. So I'll go back to HMS. So to create a rainfall gauge, you go to Components, Time Series Data Manager, and the data type is precipitation gauges, say new, and we will keep the default name gauge 1 unchanged. So we'll just provide some description, rainfall gauge for Cedar Creek, and say create, and then close the time series data manager. And then in the watershed explorer, now you will see a folder called time series data created, and inside that folder you will see precipitation gauges folder, and within that precipitation gauges folder you will see gauge 1. So after you click gauge 1, you will see that it is in incremental millimeters, which is what we want. The data that is given to us is in millimeter per hour, and the time interval by default is 15 minutes. So let's go ahead and change that to 1 hour because our rainfall data is in millimeters per hour. Then there are boxes to enter the location information for the gauge. Since we are going to have only one gauge, we are going to assume that the rainfall is falling uniformly throughout the watershed. So we really don't need to provide the information about the gauge location. So the next, we will make sure that the time interval is correct. So remember, our rainfall started on 21st of February 2005, and we want to enter the date in the same form. So 21 Feb, Feb 2005, and the start time is 01 hour 00 minutes. So it finished on the same day. So again 21 Feb 2005, and it finished at 14 hours. So the time format in HMS is 24-hour format, so don't put 2 p.m. so 14 hour, and as soon as we do that, it will create an empty table. So you will see that the first row you cannot input any information because the rainfall started at 1 a.m., which means the next reading we have is at 2 a.m. after 1 hour. So we have these empty rows. What we are going to do is simply copy the information we have in the Excel file and paste it so we don't have to manually enter all the numbers. So I'll go to Excel. So at 1 a.m. we have 0, so we will not copy that. We will copy information from 2 a.m. until 14 hours. So copy and then simply right click and paste, and you will see all the values are entered. Again, make sure the units are correct. So the unit that is given to us is in millimeters per hour. So after we input this, so let's go ahead and save the project. After we create the gauge, make sure that the values are in millimeters per hour one more time. And then we also have this rainfall hyetograph, which looks like this. So once the gauge data looks okay, we will create a meteorologic model and link this gauge to the meteorologic model. To create the meteorologic model, you go to Components and then Meteorologic Model Manager, and we will create a new meteorologic model and Met1. So if you want, you can input some description: meteor model for Cedar Creek, create, and then close. And after you do that, you will see another folder added to the Watershed Explorer, which is called Meteorologic Models. So Met1, description, unit system is metric because we have millimeters per hour. Precipitation type is specified hyetograph. Next, this is an important input here that says replace missing abort compute. So what this means is if the program finds any missing rainfall information, it will stop the simulation. So instead we will change that to set to default, which means even if there are some missing values, it will still run the simulation. So make sure you change this to set to default. The next thing that we are going to do is we will click on basins here, and right now include sub basins, it is set to no. We will change that to S. What that will do is it will link the meteorologic model to all the basins, and then we will click on specified hyetograph here in the Watershed Explorer. And after you click on specified hyetograph, you will see that all the subbasins, they are not linked to the gauge. So initially, by going to Met1 and basins, we ask the program to include all the subbasins in the meteorologic model, and now we will link all the subbasins to a rainfall gauge, which is gauge 1 that we created. So click here on none and set that to gauge 1 for all subbasins. So after you link all the subbasins to gauge 1, save your project, and now we are ready to run the simulation. So in the next unit, we will create a control specification file to run the model for the specified time step and duration, and then we will run the simulation. So for now, save your project, and this is it for this unit.